Ladies and gentlemen, good afternoon. Thanks for coming today. I'm Neil. Nowadays, big data is getting more popular and more important in our life. It is like a new generation oil, so that we need to discover and extract the new valuable information and make a new service or product to make our life become easier or more convenient. Currently, there are many solutions for running big data. Like you can use AWS from Amazon, or GCP from Google, this kind of cloud environment, or you can, like us, use on-premise environment. It is important to provide a tool or platform to extract this kind of new information. So today, I'm going to introduce how we provide the efficient and invisible data platform within Line. In the beginning, please let me briefly introduce myself. My name is Neil, and next to English is my name in Chinese. Currently, I'm a data architect and a data engineer, and in charge of Hadoop and its ecosystem in Data Labs department in Line. I have more than 5 years experience in image processing, computer vision, and pattern recognition. Okay, let's start today's topic. This is today's agenda. In the beginning, I'll briefly introduce the data platforms within Line and show you what kind of role does each platform play. We have several platforms, but I'm sorry. It is because that we don't have enough time today, so I will just only focus on the pipeline platform and analysis platform. Then finally, the data ecosystem will be introduced. I also will share you some experience that we have. Hopefully, this can help you to improve or optimize your platform as well. Okay, let's start from the the data platform within Line. As you may know, Line has launched many services in many countries, like Japan, Korea, Taiwan, Thailand, or Indonesia. Therefore, the bulk data, the huge data, like event log, transaction data, are produced in every single moment. We have got to collect and keep this data from many services, like Line Pay, Line Music, Line News, or other services like Timeline or advertisement. After we have this kind of data, our engineers and data scientists can use this data to develop a new product or optimize the current service functions. In our platforms, now we are doing the system integration, data tracking, data landing, and provide the protocolized model to normalize the data. Or you can use a mathematical model to do the A/B test, use machine learning or deep learning to predict the result, or make a recommendation system to optimize your service function as well. I believe the common techniques that we are already using. In order to handle this huge data, now we have 3 main platforms to process this data. The first one, the tracking service platform. It's like when you use your Line app, the user behavior, any button, any link that you just click, any page that you just read, this kind of log or data belongs to event log, and it will be collected and saved in this tracking service platform in real time. And the second one is pipeline platform. This is for service engineers to focus on processing their own data in the specific SLA, the service production layer. The third one, the last one, is analysis platform. And it's like its name, it is for data scientists to analyze the data or do machine learning here. Okay, let's start to talk about the pipeline platform. This pipeline platform connects to Line service systems. Therefore, on this platform, we provide several features for service engine. I will show you 3 numbers describing our pipeline platform. In this platform, right now, we process over 600 data types, which come from our line services. And today, the data scale is around 30 petabytes. And its maximum throughput is over 6.5 million messages per second. Because we have very huge data, so sometimes it is pretty difficult to manage those data sets. Pipeline platform is focused on the processing such enormous data stream. Please look at this workflow. Developers only need to focus on maintaining their own data model. Once the new definition is commit or merged into GitHub, and the new model will be delivered into each component, then the data user, like data planner, data scientists, or engineers, can use this data model automatically. It is because the protocol model has backward compatibility. No matter which version they are, or they could be used in any environment. We also use central dogma to synchronize the data flow configurations with streaming components, like Kafka or Flink. Okay, this is an example of our protocolized data model. We adopt the protocol buffer to describe our data model. The protocol buffer has several good features: extensibility, the backward compatibility, good performance, and the most important is it is pretty easy to be used. For example, please look at number 8, the event time. We provide the custom option used as timestamp to define the timestamp field, and it could be used by Elasticsearch or Hive partition. Next, after briefly introduce the data pipeline platform, let's jump into introduce you guys another platform, analysis platform. In this platform, the data scientists do the high-level analysis here. The data flow is like this. We copy the data from the service side and save the data in this analysis platform. And our data engineer will process this data, like data filtering, data cleaning, or transferring the data into warehouse. After this process, and we can connect with BI tool for reporting or provide the warehouse for data scientists to analyze the data. Finally, now we can use the same way to return the result to the service side. And the service side can use this data to optimize their products. There are another 3 numbers here. Is there anyone who can guess what they are? Okay. Currently, now we have more than 1,600 Hive tables in this platform. And 25 petabytes data is saved here. And we have more than 500 users are using this platform every day. All these 3 numbers keep growing in every single day. Until here, you may be confused. How many data science do you have? Why you have more than 500 users? Actually, this analysis platform is opened and shared with whole internal line. So it means all the line employees can access this platform by using their personal account. In fact, now we only have around 30 data scientists in our data labs department. In this platform, except IBM Cognos, Tableau, all other tools are open sourced. Something like we can use Hadoop HDFS or MySQL for storage, MapReduce, Spark for calculation engine, Hive or Presto for the query engine. Or you can use Apache Ranger, Kerberos, LDAP for security. Umbre for managing your cluster, or Airflow, Jenkins, and Carbon for scheduling your ETL batch, Flink, Flintd, and Kafka, and the Kibana, NiFi, this kind of the streaming processing tool. This is our data infrastructure of our analysis platform. We have 3 kinds of data sources. The event log from the service app, like as I mentioned before, any button you click, any page you read, this kind of event log, it is a real-time log, will be used here. This kind of data will be sent into Kafka and go through Kafka. Finally, it will be sent into Elasticsearch. In this moment, user can query the Elasticsearch and get the result they want, or connect with Kibana for reporting. Another way is to consume the data from Kafka and put it into Hadoop HDFS. And we will talk about more detail about this in next slide. If the data is from the relational database, like MySQL or Oracle, now we can use Scoop to copy the data. Other storage like another Hadoop cluster, HBase, MongoDB, Redis, or other file system like FTP, that we can use MapReduce for processing. After the data is prepared and saved in Hadoop HDFS, that we can connect with Data Hub. Data Hub is a REST API, and it maps to the HDFS directory, so the user can download the file or upload the file while using this Data Hub. Very convenient. Or you can install the Hadoop client using Spark, MapReduce, or Tez to execute your job by yourself. The last one is use Presto. Presto is a query engine, and it is developed by Facebook. It refers the Hive meta store to execute the query. And then you can connect Presto with BI tool for reporting as well. OK, let's go deeper to the architect of consuming Kafka. As I mentioned before, we have data from service databases, some other clusters, or Kafka. For relational database or Hadoop cluster, now we have many ETL batch to migrate data or copy the data. And the batch could be executed in every 50 minutes, hourly, daily, weekly, or monthly. For Kafka, except Elasticsearch, now we use Flink and NiFi to process the real-time data. You may feel weird. Why you need both Flink and NiFi? Both of them process streaming data, don't they? You can just choose one of them. Yes, you are right. But let me tell you the reason why we use both of them. Let's have some user scenarios here. The data comes through Kafka and sent into Elasticsearch, and finally go through the Kibana. User can get the real-time data by using this method. But remember, I mentioned before, we have thousands of Hive tables. So sometimes it is inconvenient to use Hive join with the current Hive table between Elasticsearch and Hive. Second one, Flink is a streaming processing tool. In real-time consume the message from Kafka and process the data. For example, in line live services, you may want to know how many people who are watching your video. So you may have a small number under your video, and it counts the number of people, +1, -2, +3, or -4. For this process, it is very good to use Flink. But if you want to use Flink to consume the data from Kafka and then put into Hadoop HDFS in real time. The first, you need to write some source code. And then, in this period, NiFi will open a file, write the data into this file, and close a file, and finally put it into Hadoop HDFS. But sometimes the user doesn't want to this complicated process. They just want to read the data via Hive as soon as possible and join this real-time data with other Hive tables. So we use Flink here. We don't need to write that many source code here. NiFi, in real time consumes the Kafka data and appends a lot of small files into Hadoop HDFS. So it is because it appends a lot of small files into Hadoop, so we have to merge this small file in every 15 minutes. This is very convenient, and the user can use the real-time data by sending Hive query. Today, we can process around 180,000 data per second by using NiFi. Other reasons that we choose NiFi, it is not only because it's low latency, high throughput, and supporting SSL encrypt, but also it has a very, very beautiful UI interface. You can use this UI interface, just drag some dialogues and the lines, and connect them to each other, and the basic flow is generated. The second one is the security. It supports the authentication and the authorization functions. So you can connect with your LDAP or Kerberos, and it can help you to control the user permissions. Like A user only can read this floor, and the B user can edit this floor. The third one, local backup. This is very important. NiFi is a cluster. You don't need to worry about if one of the nodes is dead. Even if the node is dead, the local backup will help you reload the unfinished processing after your node comes back. After talking about how we process the data and the data flow, let me introduce what kind of tool that we are using for reading or process data in analysis platform. If we said Presto, Hadoop HDFS, and Hadoop MapReduce, and Spark are the calculation engine and the storage, the following tools are our data ecosystems. They are Yanagishima, Line Analytics, Oasis, and Aquarium. Yanagishima is a web UI for Presto and Hive. User can execute a query via this tool very easily. Actually, this is developed by our line engineer. There is a GitHub URL here. You can check it later. And there's a demo video. Let's take a look. So using Yanagishima, you can select the database or table that you want and expand the table and execute the query. Or you can edit your query in this edit box or set up the variable that you want. You also supply some function and book it to a bookmark or copy it to the clipboard. Or you can reformat it. You also provide a UDF recommendation, so you can just use the recommendation that they show you and use the parameter and the variable that you want and execute the query again. And you also can transfer your result to the chart or some dialog or histogram that you want. And if you want to send your query history to your lead coworkers, and you also provide these functions. And you also have a shortcut key that you can use or the setting for edit this window. It is very convenient. Please take a look. This is the GitHub URL. Another one, line analytics. This is a reporting tool. Like in this tool, that you can see the current data status. Like in this moment, which news has how many page views, and how does the status go up and down. I'm sorry, just because of some security issue, so I have got to hide some confidential information here. ASUS is an interactive data analysis tool. You can write your source code here and execute it and show the result into a chart. It actually is pretty similar with another tool which is called sampling. Actually, and we have another section which is going to talk about more detail and only for this ASUS in whole B. And it's going to start from the 440. So please feel free to participate. The last one is Aquarium. This is a data catalog tool. Just because now we have many Hive tables, so sometimes it is pretty hard to know where the data is. And what kind of data does our platform have? So if you have this tool, it is very convenient for users to figure out the table status. For example, there is a database which is called analysis, and there's a table which is named app log, and you can have the description for this app log table. And we also can know the column definitions, and the user can easily to know the struct of this table. Like there's a column which is named log, and we can know the log format is a JSON format. And another good function is you can know the table lineage. Like in this example, that you can know the chat history has the dependencies with app log. After introduce our data ecosystem, next we are going to talk about our security. As I mentioned before, this platform is open and shared with whole line employees. So that we need a very high level security. Although you can access this platform, but it doesn't mean that you can read all of data. Our platform identifies each user and control each permission. Our platform has individual security systems. It is independent of line internal security systems. We have our own LDAP and cables. Although you are a line employee, if you cannot pass our security identifications, you are still not allowed to access into our platform. Today, now we have 4 identities right now. The real user, and this user's group, and the system user, and the system group. These kind of 4 identities. The user flow is like this. You can access into the gateway or step server from your laptop and pass the internal cables to access into the client server. Until here, the authentication is controlled by Office cables. After you access into the client server, since here, the user authentication is controlled by our individual LDAP and cables. And the authorization is controlled by Apache Ranger. After you pass all of these identification, and you are allowed to access our Hadoop. Why do we need these kind of complicated identifications? It is because our platform has many confidential data, like line pay, billing. Therefore, now we need to restrict the permission for each user. In our platform, we also provide a sign-out system. So user can sign out his account anytime he wants. We provide a UI, and the user can just go to the UI from your laptop and check your personal information and a password. After that, our system will go to the Office Active Directory and get your personal information, like your employee ID, your department, your email address, and your name. After that, I will automatically to create your personal account in our LDAP and Kerberos. HDFS user home directory will be created at this moment as well. When you finish this work, you are already allowed to use our platform. Of course, in this moment, you cannot read anything except some public data, like country code. If you want to read the service data, you may need to apply the permission via workflow. After you get the data owner's approval or a project manager's approval, then you are allowed to read these service data. After security, let's talk about the monitoring. When you are running a big cluster or platform, it is necessary to do the basic monitoring. Currently, there are many tools like Prometheus, Ganglia, Grafana, or some users can use Splunk to monitor their Java JVM, network traffic, and disk capacities. But today, I'm going to show you another monitoring, the cluster monitoring. If you can say the basic monitoring in the previous slide is a server monitoring. In this slide, the cluster monitoring will be talked. The file status, usage, where's a small file, and which file is an empty file. Who created this file? And when this file is created today or yesterday, and so on. All of these status and information are need to be monitored. If you have any experience of running a big cluster, you may know the small file is like a cluster killer. It will increase the burden of net node. Once your net node is dead, it means your cluster is dead as well. So let me show you how we monitor all of these. There are 2 net nodes for HA, and the 3 general nodes. I assume that you are already familiar with these. But today, now we prepared the 3rd net node. This net node is like other 2. You also synchronize the metadata from general node in real time. And this 3rd net node always on standby. And it will never, ever become the active one. So we can use this 3rd net node and its metadata. No matter how we analyze it or monitor it, this 3rd net node won't affect the current net node 1 and net node 2. This is how we do our monitoring. If you already find you have a lot of small files in your cluster, in your HDFS, I have got to say, I'm sorry, just because that you already found the unlimited time bomb in your cluster. But don't worry, I'm going to show you how to lose it, how to tune your cluster. Usually, small file will increase the net node's burden because net node needs to remember all the location of all files. Too many small files will cause the metadata, the FS image, gets bigger. It is too heavy for net node. So we have better to decrease the small file as many as possible. There are 5 parameters and configurations here. They are related with the Spark history and the young log. Actually, if your cluster is a big cluster, and there are a lot of jobs which are running every day, it is better to set up this. It is because you don't need that many logs. Just keep them for 2 days. I suppose that it should be enough. Another one is to optimize your Hive. These configurations can force the small file get merged when you execute a Hive query. When the file size, the average size is smaller than the threshold, the merge function will be triggered. You can also use the alter table concatenate command to merge the small file that you already have. But this command currently only works for ORC file and RC file. Okay, after share you guys some experience that we have, let's jump into the conclusion. When you run a big data platform, sometimes you may feel frustrated, but don't be worried. What is required? Just be patient. And how to achieve the result? Just keep trying the error and never give up. This is it for today, and thanks for hearing and coming. If you have any question after today's session, and I will have a Q&A time for ask to the speaker. You can ask me or other engineers. And thank you very much. Thanks for your participating. Thank you.